Hey Mathwits! Today we're going to learn how to do double-digit multiplication. Before we get into double-digit multiplication, there's one concept that we can learn that makes it a lot easier. It's called expanded form. E X P A N D E D F O R M. Let's say you have the number 235. This number is written in standard form, which is what all numbers are commonly written in. If we want to draw this out in pictures, we know that we have 200. So let's say we're using squares. And this represents 200 because we're using the base 10 system. So this would be 100, this would be 100, and that's the 2. For the 3, we would have 1, 2, 3 sticks of 10. And that is 30 for the 3. For the 5, we would have 5 blocks of 1. Now, we can see that we have 200, 30, and 5. If we add these all together, that equals 235. The same as our number in standard form. Writing our numbers out based on their place value is called expanded form. Now, let's get into our first double-digit multiplication problem. Now, let's say we have 23 times 3. Or we could also say this is 3 sets of 23. If we draw out 23 in base 10 blocks, that's 2 10s and 3 1s. So that's 20, 3, or 20 plus 3. And this is just like, and sorry, since we're multiplying by 3, we have this 3 times. But drawing this out 3 times is a little time consuming, and if this number were higher, it could end up being confusing. So, instead of doing everything all at once, we can take this down step by step and separate it so that it's easier to process. Let's take our 20 and multiply it by 3. So we have these 10s, another set of 10s, and another set of 10s. So now we have 20, 30, 40, 50, 60. And now we'll do this 3 and make 3 sets of it. So we have 3, another set of 3, and another set of 3. Now we have 23 times 3, but now we know that there are exactly 3 sets of 23. There's 60, and 1, 2, 3, 4, 5, 6, 7, 8, 9. So, in total, we have 60 in our blocks of 10 and 9 in our blocks of 1. If we combine them, that's 60 plus 9, which equals 69. So we know 23 times 3 equals 69. Breaking multiplication down like this isn't just when we use pictures. We do this when we multiply just using numbers as well. if we write it out in vertical form, we would do each number one by one. So we have our 3 on the bottom, and we use this to multiply by the 3 and by the 2. We always start with our ones place because that's the smallest number. So we have our 3, and we're multiplying it by the 3 in the ones place of 23. So 3 times 3, if we look at our multiplication chart, we can see that it equals 9. Now we move on to the 2. 3 times 2, as we can see, is 6. So we put the 6 next to the 9. And we can see we get the same answer. Let's do another problem. Before we get into our next multiplication problem, we're going to do one addition problem to refresh our memory on a core concept. We'll do 15 plus 6. 5 plus 6 is 11. So we put the 1 of the ones place of 11 on the bottom and move the 1 of the tens place to the top. Now this one is in the tens place, and this one is also in the tens place. So we add these together to get 1 plus 1 equals 2. This concept is the same in multiplication. If we were doing 15 times 6, we could write out the boxes again with 110 for the 1 and 5 ones. However, we'd need to draw this out 6 times, and that's a real hassle. So let's just do it by the numbers. 15 times 6. First, we need to do the 6 times the 5 because they're both in the ones place. And looking at our chart, we know that 6 times 5 equals 30. Since 30 has 2 place values, the 0 being in the ones place goes on the bottom. The 3 being in the tens place goes on the top. This 1 times this 6 is next, and 1 times 6 equals 6. So we would put the 6 on the bottom, but since we also have this 3, we add this 3 to the 6 that we have right here, meaning we will do 3 plus 6, and 3 plus 6 equals 9. So our number that goes here is 9, because we did 5 times 6 equals 30, bring the 0 down, put the 3 on top, 1 times 6, 1 times 6 equals 6, and we add the 3, getting us 9. Now, this is a lot faster than drawing this out 6 times and counting up all the numbers. If it's hard for you to visualize to do 6 times 5, then 6 times 1, you can also draw it out in an array box. After expanding our number into 10 plus 5, we can draw a box and separate it like this, so that this side is 10 and this side is 5. We're multiplying by 6, so now we have 10 and 6 plus 5 and 6. And the total inside of this box is our answer. If you don't have your multiplication chart and you're better at doing easier multiplication, then I would recommend doing this method. For this side of the box, we have 10 on this side and 6 on this side. So we can write it as 6 times 10. 6 times 10, we can see, oh, it's not on this chart, sorry. 6 times 10 is 6 sets of 10, which is 60. And 6 times 5, which is on this chart, is 30. So, since this small rectangle is 30 and this big rectangle is 60, we can add these together to get our total, which is 90, the same as we got doing this method. This box is helpful if you're much better at doing multiplication with visuals. Now, what if you're doing a problem where both numbers are double digits, like 42 times 12? Once again, we can expand both of these numbers into their expanded form. 42 has 4 tens, and 2 ones. So that's 40 plus 2. 12 has 1 10 and 2 ones. So that's 10 plus 2. If you want to do this visually, we can break this down so that we have 40 plus 2 on one side and 10 plus 2 on the other. So that we have 4 sections. In this box, we'll do 10 times 40. In this one, we'll do 10 times 2. In this one, we'll have 40 times 2. And in this one, we'll have 2 times 2. Instead of doing 42 12 times, this way makes it much easier. Let's start at the smallest box. 2 times 2, we can see, equals 4. So this box is 4 in total. In this box, we have 10 times 2, or 2 sets of 10. We know that if we have 2 sets of 10, that's just 10 2 times, or 10 plus 10, which equals 20. This box is the same, with 2 sets of 40. So 40 plus 40 equals 80. A pattern that we can see in both of these boxes is that we have 10 with a 0 on the end times 2, and 40 with a 0 on the end times 2. If we look on our multiplication chart, we can see that if we take out this 0, since we know anything times 0 equals 0, this looks like 1 times 2. And we can see that 1 times 2 is 2. We have the 2 right here, and we're adding the 0 on at the end, which gets us 20. The same goes for this box. So we have 4 times 2, if we don't look at the 0, and 4 times 2 equals 8. We have this 8 right here, and there's 1 0 in the multiplication problem, so there's 1 0 in the answer. We can use this trick to do 10 times 40. There's 2 zeros, but if we ignore them, it looks like 1 times 4. and we can find 1 times 4 on our multiplication chart. 1 times 4 equals 4. There's 2 zeros in the problem, so we can add 2 zeros on the end of the 4. And our answer is 400. Now that we have our answers for each of these boxes, we can add them up. 400 plus 20 is 420. 420 plus 80 equals 500. 500 plus 4 equals 504. And that's our answer to 42 times 12. However, this still was kind of a lot of work, so we can do it vertically with 42 times 12. Like before, we can start with our 2. 2 times 2 is 4. 4 times 2 is 8. Now, we have to move on to multiplying by this 1. However, this 1 is in the tens place, so we can't just keep adding numbers onto this side. If we want to break down this problem to make it easier to look at, we can do 42 times 10 and 42 times 2. We know the answer to 42 times 2, which is 84. Now we have to do 42 times 10. But like I said, we can do 42 times 1 while ignoring the 0, and then add a 0 on at the end. So let's put our 0 and do 42 times 1. 42 times 1 plays into our identity property, which we learned is anything times 1 equals that anything. So 42 times 1 equals 42. And we know that 42 times 10 is 420. We can now combine these two to get our answer, which is 504. If you want to combine these into this one problem, we take this 0 and we put it under the 4 so that it's a quote-unquote null 0. This is our placeholder so that we know we're doing 42 times 10, as we can see when we break it apart. Now we can do 1 times 2, which is 2, and 1 times 4, which is 4. And you can see how this gets compressed into this one problem. Now that we have 84 from doing 42 times 2 and 420 by doing 42 times 10, we can add them together to get 4, 0, and 5. 504, which is our answer. I know this was a lot to take in, Mathwits, but I hope this helped. Thanks for watching!